A starburst galaxy is a galaxy undergoing an exceptionally high rate of star formation, as compared to the long-term average rate of star formation in the galaxy of the star formation rate observed in most other galaxies. In a starburst galaxy, the rate of star formation is so large that the galaxy will consume all of its gas reservoir, from which the stars are forming, on a timescale much shorter than the age of the galaxy. As such, the starburst nature of a galaxy is a phase, and one that typically occupies a brief period of a galaxy's evolution. The majority of starburst galaxies are in the midst of a merger, a close encounter with another galaxy. Well-known starburst galaxies include M82, NGC 4038, NGC 4039, and IC10. Starburst galaxy definitions. Starburst galaxies are defined by these three interrelated factors: the rate at which the galaxy is currently converting gas into stars, the available quantity of gas from which stars can be formed, a comparison of the timescale on which star formation will consume the available gas with the age or rotation period of the galaxy. Commonly used definitions include continued star formation, where the current SFR would exhaust the available gas reservoir in much less than the age of the universe. Continued star formation, where the current SFR would exhaust the available gas reservoir in much less than the dynamical timescale of the galaxy. The current SFR, normalized by the past averaged SFR, is much greater than unity. This ratio is referred to as the birthrate parameter. Starburst galaxy triggering mechanisms. Starburst galaxies feature a large amount of cool molecular gas in a small volume. Galaxies in the midst of a starburst also frequently show tidal tails, an indication of a close encounter with another galaxy, or are in the midst of a merger. Interactions between galaxies that do not merge can trigger unstable rotation modes, such as the bar instability, which causes gas to be funneled towards the nucleus and ignites bursts of star formation near the galactic nucleus. Types of starburst galaxies. Classifying types of starburst galaxies is difficult, since starburst galaxies do not represent a specific type in and of themselves. Starbursts can occur in disk galaxies, and irregular galaxies often exhibit knots of starbursts spread throughout the irregular galaxy. Nevertheless, astronomers typically classify starburst galaxies based on the most distinct observational characteristics. Some of the categorizations include blue compact galaxies. These galaxies are often low-mass, low-metallicity, dust-free objects. Because they are dust-free and contain a large number of hot, young stars, they are often blue in optical and ultraviolet colors. It was initially thought that BCGs were genuinely young galaxies in the process of forming the first generation of stars, thus explaining the low metal content. However, old stellar populations have been found in most BCGs, and it is thought that efficient mixing may explain the apparent lack of dust and metals. Most BCGs show signs of recent mergers and/or close interactions. Well-studied BCGs include DIZW18, ESO338, IG04, and HARO11. Blue compact dwarf galaxies are small compact galaxies. Green P galaxies are small compact galaxies resembling primordial starbursts. They were found by citizen scientists taking part in the Galaxy Zoo project. Luminous infrared galaxies. Ultraluminous infrared galaxies. These galaxies are generally extremely dusty objects. The ultraviolet radiation produced by the obscured star formation is absorbed by the dust and re-radiated in the infrared spectrum at wavelengths of around 100 micrometers. This explains the extreme red colors associated with ULIRGs. It is not known for sure that the UV radiation is produced purely by star formation. and some astronomers believe ULIRGs to be powered by active galactic nuclei. X-ray observations of many ULIRGs that penetrate the dust suggest that many starburst galaxies are double-core systems, lending support to the hypothesis that ULIRGs are powered by star formation triggered by major mergers. Well-studied ULIRGs include UP 220, hyperluminous infrared galaxies. Wolf-Rayet galaxies. Galaxies where a large portion of the bright stars are Wolf-Rayet stars. The Wolf-Rayet phases is a relatively short-lived phase in the life of massive stars, typically 10% of the total lifetime of these stars, and as such any galaxy is likely to contain few of these. However, because the stars are both very luminous and have very distinctive spectral features, it is possible to identify these stars in the spectra of entire galaxies, and doing so allows good constraints to be placed on the properties of the starbursts in these galaxies. Ingredients of a starburst galaxy. Firstly, a starburst galaxy must have a large supply of gas available to form stars. The burst itself may be triggered by a close encounter with another galaxy, a collision with another galaxy, or by another process which forces material into the center of the galaxy. The inside of the starburst is quite an extreme environment. The larger amounts of gas mean that very massive stars are formed. Young, hot stars ionize the gas around them, creating H2 regions. Groups of very hot stars are known as OB associations. These stars burn very bright and very fast, and are quite likely to explode at the end of their lives as supernovae. After the supernova explosion, the ejected material expands and becomes a supernova remnant. These remnants interact with the surrounding environment within the starburst and can be the site of naturally occurring mazes. Studying nearby starburst galaxies can help us determine the history of galaxy formation and evolution. Large numbers of the very distant galaxies seen, for example, in the Hubble Deep Field are known to be starbursts, but they are too far away to be studied in any detail. Observing nearby examples and exploring the characteristics can give us an idea of what was happening in the early universe as the light we see. For these distant galaxies left them when the universe was much younger. However, starburst galaxies seem to be quite rare in our local universe, and are more common further away, indicating that there were more of them billions of years ago. All galaxies were closer together then, and therefore more likely to be influenced by each other's gravity. More frequent encounters produced more starbursts as galactic forms evolve with the expanding universe. Well-known starburst galaxies. M82 is the archetypal starburst galaxy. Its high level of star formation is due to a close encounter with the nearby spiral M81. Maps of the regions made with radio telescopes show large streams of neutral hydrogen connecting the two galaxies. Also, as a result of the encounter, radio images of the central regions of M82 also show a large number of young supernova remnants, left behind when the more massive stars created in the starburst came to the end of their lives. The antennae is another well-known starburst system, made famous by a stunning Hubble picture, released in 1997. List of starburst galaxies. Gallery.